Determine which inequality statement is true. We're going to look at the last one together. Well, if this is 0, -5 might be somewhere around here. Then -5.2 might be around here. And -5.21 would be right next to it, but a little bit farther to the left. So is -5.2 less, or is -5.21 less than the other? -5.21 is lower than -5.2. So statement B, this is statement B, is the one that is true. For this one, it is a decision on which one you feel does not belong. You can argue any of them do not belong, but you need to be able to support your reasoning. So I'm going to give you a second to think about it. One might argue that A does not belong because it's the only one with that open boundary. You could also say that B does not belong because it's the only one pointing to the left or for less than. Or you might say that C does not belong because it's the only one that doesn't have its boundary number on -4. Here, these are supposed to be matched up with the graphs for the inequalities on the previous slide. To solve these, we would divide by 2 on both sides, and that would give us x is less than or equal to -4. That would be the second one because it was the only one that went to the left. For this one, we would add 1 to both sides, so this would say x is greater than -4, which would be the first one. And for this one, we would subtract 6 from both sides, which would give us x is greater than or equal to, well, 6 minus 6 is 0, which was C, since it was the only one that did not start on -4 as its boundary number. Do you think we can solve inequalities by using if-then moves the same way we solve equations? Why? Just like when we had the inequality from previous lessons. Can we just pretend that that's an equal sign and solve it the same way? We have this number line here, which is not in your book, but is up here on the screen. When solving equations, we added the same number to both sides or subtracted the same number from both sides, and the solution to the inequality or to the equation did not change. Let's test and see if that also works with inequalities. We're going to start with an inequality statement that we know is true by using some numbers shown on the number line. So here's an example. We know 3 is less than 6. Here is 3. Here is 6. We know that's true. How does the number line help us compare 3 and 6? Well, since 3 is on the left, we know that it is less than or lower than the number on the right. So now we're going to try and add values to these numbers to see if we can maintain the same inequality. So let's say I add 5 to both of these. Well, then 3 plus 5 is 8, and 6 plus 5 is 11. So now I have 8 and 11. Is 8 still less than 11? Well, yeah, it's still to the left. So the new inequality statement is still true because the 8 is to the left, so it is less than. What if instead we subtracted a number? We had 3 and 6 to start with. What if we subtracted 9 from both of them? Well, 3 minus 9 would be negative 6, and 6 minus 9 would be negative 3. Here's negative 6. Here's negative 3. Is negative 6 still less than negative 3? Yeah, the order stays the same. The red one is still to the left. So we can add and subtract without changing the inequality symbol. So here we are going to start by adding 3 to these. Well, 2 plus 3 would be 5, and 10 plus 3 is 13. 13 is still bigger, so we open the mouth of that symbol to the 13, and that is true. This one says add a half. 3 1/2 plus a half gives us 4. The symbol was facing this way. 1 plus a half is 1 1/2. Is 4 bigger than 1 1/2? Yeah. What if we add 0? Well, then they stay the same. 4.2, the symbol, and the numbers both stayed exactly the same. Is it still a true sentence? Yes, negative 4 is smaller than 10. What if I add negative 2.1 here? Well, negative 2.1 and negative 1 would make negative 3.1. My symbol is facing this way. Negative 9 and negative 2.1 would make negative 11.1. Negative 3.1 is still bigger than negative 11.1. So that one is also true. If I oops, I messed this one up because it was supposed to be subtraction. Subtract a half, that would give us 3 and a half. 3 is bigger than a half, so that's still true. This one says subtract a negative 4. Remember, if we subtract a negative, that's the same thing as adding its opposite. So 25 plus 4 would give us 29, and 13 plus 4 is 17. The symbol was facing this way, and 29 is greater than 17, so that one is true. For problems 6 and 7, solve the inequality by using this if-then moves and graph the solution set. So subtract 7 from both sides. That gives us x. The symbol is facing this way. 40 minus 7 is 33. So it's a closed dot on 33. X is greater, so we're going to point to the right. This one we would add 6 to both sides. The symbol is facing this way. 12 plus 6 is 18. It will be an open circle. It says 18 is smaller than y, so y must be bigger. When solving equations, we can also multiply both sides of an equation by the same number, and this equation doesn't change. It just helps us find our solution. And that's because we get an equivalent equation. So we're going to test that with inequalities also. Again, we're going to start with something that we know. We know that 4 is greater than negative 1. Here's negative 1. Here is 4. We know 4 is bigger because it's to the right. So now we're going to multiply each side of the inequality by the same number to see whether it remains true. Let's multiply by 2. If I multiply by 2, 4 times 2 is 8. Negative 1 times 2 is negative 2. Our symbol was facing this way, so let's check and see if that's true still. Here's negative 2, and here is 8. Is 8 bigger than negative 2? Yes, it is to the right. What if we divided by a number instead? What if we divided by 4? So we had originally 4 was greater than negative 1. What would happen if we divided both sides by 4? 4 divided by 4 is 1. Negative 1 divided by 4 would be negative 1/4. So here's negative 1/4. And here's positive 1. Is it still greater than negative 1/4? Yes, that is still true. So we can multiply by the same number or divide by the same number without changing the inequality to a false statement. Do you think that it will always remain true if we multiply or divide both sides by the same number? We multiplied both by 2. Here we divided both by 4. Let's look at some cases in the next problem found in your workbook. Okay, so half, we're multiplying by half. Half of negative 2 would be negative 1. Half of 10 is 5. Our symbol faced this way. Is negative 1 less than 5? Yes, that is true. Divide by 5. 25 divided by 5 is 5. 10 divided by 5 is 2. And our symbol faced that way. Is 5 greater than 2? Yes, 5 is bigger than 2. But if we multiply by negative 2, 3.5 times 2 would be 7, but 3.5 times negative 2 would be negative 7. 1 times negative 2 is negative 2, and our symbol faced this way. Is negative 7 greater than negative 2? No, negative 7 is to the left. So that one is false. Divide by negative 4. Negative 4 divided by negative 4 is positive 1. Keep our symbol. 16 divided by negative 4 would be negative 4. Is 1 smaller than or equal to negative 4? No, 1 is bigger than negative 4, so that one is false. Divide by 0.5, negative 0.5. 1 divided by negative 0.5 is positive 2. Negative 9 divided by negative 0.5 is positive 18. Is 2 bigger than or equal to 18? No, it is smaller than 18. So what do you notice about when it was true and when it was false? All of the ones that came out false were when we multiplied or divided by a negative number. But they were true when we multiplied or divided by a positive number. So in these ones, in order to make them true, we would need to change the symbol here to rewrite them as a true number sentence. Here are some notes on what types of things we can do when trying to solve inequalities. This one shows adding a number, and this one shows subtracting a number. And you see here that the symbol was written the same way. This one shows multiplying by a number, and it says if it was positive, the symbols face the same way, but if it was negative, it goes the opposite direction. And this one shows dividing by a number. If that number is positive, those symbols faced the same way, but if the number was negative, we had to change the direction of the symbol. So we call this preserving the symbol versus reversing this symbol. So the only time where we have to change the symbol is if we multiply or divide by a negative. All other times it stays the same direction. So for problems 13 and 14, solve the inequality using those if-then moves, graph the solution set, and explain why it is either preserved or reversed. So here, it's multiplied by 1/2. So we would divide by a half on both sides. Dividing by a positive number does not reverse the symbol. So this one we're going to say is preserved because we divided by a positive. So 4 divided by 1/2. Remember, you can think of that as multiplied by the flipped over version. So 4 times 2 over 1, or 4 times 2, would give us 8. The symbol's preserved, so don't switch it around. And then the half divided by a half would just leave us with the x. So we put a closed dot on 8, since it's got that underline. And this is saying 8 is bigger than x. So that means x is the smaller of the two, so we're pointing to the left. Here we're going to divide by -3, so the symbol has to get reversed. Well, divided by -3 would give us -4, and we have t. So that's an open circle on -4. And it says t is less than, so we're pointing to the left. Make sure your workbook is filled in for lesson 20 and check back for lesson 21 soon.